It wasn't easy to convince governments in the immediate post-World War II era to keep spending money on military equipment and to maintain a strong force. After all, the Axis had been defeated and it was a brave new world. Peace in our time, as they say. Until it wasn't. The Berlin airlift and the Korean War were wake-up calls not even a cash-strapped nation could ignore, and thus we set the scene for the first generational jump in jet design, the Hawker Hunter. Hello everybody and welcome back to Military Aviation History. I am your host Bismarck and this episode is ad-free, sponsored by my Patreons. If you like what you see today, please consider supporting the channel either via Patreon or PayPal, as this helps us travel to museums, sort out the logistics and get this sort of content into your living room. Today we are at Clin in Payerne, Switzerland, taking a look at the Hawker Hunter, a British jet fighter from the early Cold War era, a plane that had to jump through many bureaucratic hurdles before setting out to be the next best thing in jet design. Just after World War II, Britain put into motion F.43-46 and F.44-46, meant to eventually substitute their first run of jet fighters, the Gloucester Meteor and the de Havilland Vampire. Little came of these. The specification itself were not used for the immediate future. Throughout this time, the Hawker Company, known for their Hurricanes and Tempests, for example, from World War II, did propose their P1040 project based around the Rolls-Royce Nene jet turbine. The Air Force itself was not interested, and had it not been for the Admiralty, well, the plane would never have seen the light of day. As Sidney Camp, head designer at Hawker, once said, "Thank God for the Navy." In any case, N746 was released, allowing Cam to submit his own design, which was adopted as the Hawker Seahawk. However, as aircraft design, technology and equipment rapidly passed beyond the Seahawk's abilities, Hawker looked to development of the next iteration of its jet-powered aircraft. Taking the Seahawk as a template, Hawker commenced work on P1052. It's going to be a lot of P's in this video, by the way. One of the main features were the wings, now swept backwards. Flying early trials over Boscombe Down, the aircraft exhibited many flaws. However, overall, it was actually considered to be a solid platform to work with. One of the modifications that's now happening is that the plane's wings were swept even more further backwards and that the fuselage had to be modified to allow a straight-through jet pipe. The real issue lay, however, with the TAE engine, which was a lost cause at this point, so a return to the Nene was actually needed, prompting P1081. Around this time, Australia, who had been largely sponsoring the project out of their own interest to replace the aging Meteors, dropped out. Just a short while later, P1081 actually crashed itself, and although the plane was largely intact, the project had so found its natural conclusion. Nevertheless, CAM had finally been able to have the attention of the Air Ministry and it re-evaluated its design. P1081 had ended in failure and in the death of a test pilot, Trevor Wade, but the doors had now opened just enough to squeeze through a new project. Turning to the Rolls-Royce AJ65 turbojet, later known as the Avon, a new powerful engine of 6,500 pounds of thrust proved sufficiently future-proof. Alone, this provided similar thrust to actually the Meteor's two-engine setup. This finally started to fit the bill of F.43-46. That was a couple of years old at this point, so new specifications rolled out, F.348. Based on the Hawker aircraft, it called for an interceptor capable of countering high-altitude jet bombers that were starting to appear. The specifications on performance were harsh, but necessary, with speed, climb and firepower and ceiling setting a very high bar. P1067 emerged to tackle the new specs. This new design appeared very similar to P1081 from afar, but showed many different changes. After some back and fro, the air intakes were now properly moved into the wings. Cam himself didn't like this, but came around eventually. The fuselage became more circular. The cockpit space was increased and the tailplane was swept even further back, and weaponry was changed from the initial proposition of 4 to 2 cannons. In fact, an early planned version of the aircraft called for a single 4.5-inch recoilless gun, but that was abandoned for the better. Eventually, the firepower question resulted in one of the neat features, as the designers felt the plane should, in fact, be running around with at least 4 guns instead of the now proposed 2. Thus, space was found just behind and below the cockpit, where a removable gun pack was installed featuring 4 30mm Aden guns with 135 rounds per gun. This pack could be demounted and another one installed, potentially accelerating turnaround time as the aircraft was being restocked. To extend the firing time, the guns could be paired so as to double the 7 seconds of Commonwealth-sponsored fireworks. It should really be said that around this time, the early 1950s, the P-1067 had offensive firepower that was unmatched by any other aircraft. During testing, certain deficiencies emerged, although the aircraft itself flew very well. The lack of powered controls, as on the Sabre, became another point of criticism. The air brake too was a headache, causing the plane to violently nose down. By May 1953 then, the first Hunter F-1 was conducting combat trials, and suddenly a glaring omission of the design became obvious. It had only a range of 80 miles. Fuel supply had, in the quest for speed, during the troubles with the air brakes and the constant back and forth with the Air Ministry, been pretty much, how to put this, forgotten. The guns caused issues too, as the gas produced by the 30mm Aden guns actually caused the Avon engines to surge. A solution was to reduce the amount of fuel going into the engine every time the guns fired, but this was a suboptimal workaround, not a fix. Only later Avon engines proved to be the ultimate fix. And there is some general discussion whether Hawker's own Sapphire engines would not have been a better fit for the Hunter. The recoil and the nose-down tendency on firing also negatively influenced the Hunter's ability as a gun platform. Ejection casings were also unduly damaging the fuselage, so the aircraft actually received case injection bulges on the side of the aircraft so that these could clear the design properly. Although fixes and workarounds were able to overcome all these teething issues, the Mark I was essentially a failed production run. Subsequent production runs of Mark IVs and Vs would implement multiple improvements. Faster with new engines and with a larger fuel capacity, the Hunter was coming into its own. External fuel tanks could also now be added, and the RAF felt confident enough to send the aircraft for its basing in Germany. It is at this point that Hunter goes back to the P-1083, the aircraft it had designed to go transonic. A new one is built based on a new engine, even more fuel tanks and new wings, designated the P-1099, which became the Mark VI. Fleet-wide introduction of power controls also became standard at this point. A dogtooth was added to mid-length of the leading edge of the wing to offset a tendency to pitch up during maneuvers. Gun muzzle deflectors were also added, offset by 90 degrees from the aircraft. This caused less gas to enter the engines, the Avon engines, and directed it downwards. This actually conveniently offset the nose-down tendency on firing the gun. The Mark VI is sometimes seen as the definite version of the Hawker Hunter. And before we jump aboard this one, here behind me, bearing the Swiss colors, let me quickly go over the story of how they came to Switzerland. The aircraft you see here is the Hawker F Mark 58. essentially a redesignated Mark 6. After Switzerland had integrated the Vampire and Venom, a new aircraft was needed to modernize the force. After snooping around a bit, demonstration flights of aircraft were conducted. Not only did the Hunter demonstrate good handling, excellent speed and firepower, but the demonstration aircraft, not the pilot, was apparently awarded the Swiss Alpine badge following the flight, as the aerobatic maneuvers it pulled off in the steep valleys of this country had enthralled the audience. 3 series of aircraft were ordered, the first numbering 100 aircraft and the second and third with 30 each. These were known as the Mk.58As, as they were refurbished second-hand aircraft. In metric, the Mark 6 has a length of 14, a wingspan of 10.2 and a height of 4 meters. It is powered by a single Avon 207, roughly 10,000 pounds of thrust. It can achieve a top speed of 1,150 kilometers an hour, has a range of 1,000 kilometers. Empty, the aircraft weighs around 6,300 kilograms and it has a maximum takeoff weight of 10,700 kilograms. It comes equipped with 4 30mm Aiden guns and can load up additional pylons with rockets, bombs or drop tanks. And in the back we obviously have the drag chute for the aircraft to slow down after landing. Right below the gun package we have these bulbs. The soldiers, the men that back in the day called them sandrines. You can look up the reason for that yourself. Essentially what is meant to happen here is that the gas that is emitted also from the guns firing is emitted backwards away from the actual wind inlet for the Avon engine. So I'm on the starboard side of the Hunter and here we've got essentially the muzzles of the guns. Well, as you can see, there are these outlets here which go 90 degrees down, and this is the fix that I talked about when it came to the nose down tendency of the aircraft on firing the Aiden guns. Yeah, the gas is emitted 90 degrees downwards and it counteracts that so the plane doesn't change its angle of attack while firing. It's an easy fix, it's an ingenious fix. It also took them a couple of years. Right, on the Hawker Hunter, as you can see, the air brakes here, they aren't really flush inside the design. And this is one of those nightmare stories when it came to the Hawker Hunter on how to get these to work properly without really influencing the flight characteristics of this plane too much. Eventually they got it right and it worked, but it was never really such a beautiful part of the aircraft because, yeah, it just stands out. So I find myself in the Hawker Hunter's cockpit. Now this version that I'm sitting in right now is the trainer aircraft version, since this is the one that is accessible. However, it should give you a good idea of how the cockpit actually looks. Now, immediately you can tell that yes, there is already this progression to the sort of modern jet design, but it's still a little bit archaic in a sense that it's not as clean maybe as some of the more modern aircraft out there. It's also slightly cramped, although I can still move around quite nicely. Obviously, this being a trainer, space inside the cockpit is also somewhat different to the actual fighter and fighter bomber version in the aircraft. Now, one thing that I will mention from the start is once you get inside, I actually thought that I would have to lower myself even more. I'm pretty much as low as I can. But the gun sight, which is installed right in front of me, pretty much obstructs half of the instrument board below it. And I really have to sort of scoot down and look around to see properly what's going on. Now, I imagine that I can maybe change the seat a little bit more to give myself a better view, and that if I was to be smaller, then this would not be an issue. But for me, not exactly ideal. Also, I'm not really quite sure what will happen to my skull if I actually close this aircraft up. Alright, so let's have a closer look at the Hunter's cockpit. Definitely an interesting one, since it does incorporate some of the new systems that started rolling out throughout the service life of this specific aircraft. To the direct left, you have the oxygen inflow indicator, with a green lever further back regulating the actual flow. Forward of this, you have the throttle control, simple push and pull. It incorporates the high-pressure fuel cock. Fully back, the fuel supply is cut off completely. Moved forward slightly, the fuel flow provides enough fuel for idle RPM. Once moving forward into idle RPM, a spring-loaded catch secures the idle position so that the pilot cannot accidentally pull beyond it and shut off the engine. The button is your press to transmit on the radio, while the air brake control switch is located next to it. The air brake is actually linked to the undercarriage and will always retract and remain retracted if the gear is lowered. A low pressure fuel cock is located between the pilot's seat and the throttle control. Below the throttle, trim control for your rudder and aileron with respective indicators. Forward of this, the tailplane standby motor control, an emergency motor taking over control of the electrical variable incidence tailplane, but it only provides about a third of the power compared to the main motor. Beyond this, you have the gun sight dimmer and tactical reticule selector and the brake pressure, and the emergency gear control is to the left of that. Moving up top to the left side near the closing catch of the canopy, you have your drag chute control, nicely isolated from accidental bumps, which would not be beneficial. Below it, the quality of life switches for oxygen and cockpit pressure, as well as temperature. Moving towards the instrument board, to the left, not that easy to find, the undercarriage position indicator with a corresponding warning light. Next to it, the undercarriage selector push buttons, flanked by the emergency flap control and the flap position indicator. Above this are the switches to turn on and off the aileron and elevator servos, with a pitch trim indicator set to the right. A Mach meter is set below it. Moving to your basic instruments, top left, your speedometer indicated in kilometers an hour. Below that, your altimeter in feet. A gyroscopic artificial horizon sits in the top center position with a standby next to it to the right. Below that, a vertical speed indicator, while an HDI rounds up the collection in the lower central position. Set to the right of your main instruments, the engine temperature and RPM indicator. Most of the following gauges from now on would usually be on the starboard side of the pilot, but since this is a trainer, we find them either in the central position here on the instrument board or in a central pedestal located between the two crew positions. The fuel content gauges indicate the remaining fuel in sets of hundreds of pounds. The left and right setup corresponds to the fuel tanks. You also have respective pump controls, warning lights and fuel transfer switches set right below them. To the left, not shown, the accelerometer. The UHF and VHF, obviously more modern sets than in the original Hunters. After all, Switzerland flew them for about 30 years, only retiring them in 1994. This is why you will also find a radar warning receiver with accompanying chaff and flare controls in case of brown alert, something the first Hunters would not have had. An IFF system is also included. In the starboard position, the controls and gauges are more or less mirrored, although as you can see, they are arranged somewhat differently. Originally, the Hunters also had a gyroscopic gun sight like the Mark V, for example. And of course, I'd be remiss to ignore the whiskey compass up top and of course the all-important clock. Moving on to the final piece, the flight stick. This one was really comfortable and well designed in my opinion. It features your tailplane incidence control and on top 2 push buttons for your cannons and ordnance, with corresponding safety catches of course. The lever at the back is for the hydraulic brake control. Right, that pretty much sums it up. The aircraft features a Martin Baker ejection seat for convenient exit of the aircraft in case of an emergency. The Hunter story does not stop here. While it became a staple in the British lineup, it did reasonably well on the export market and signaled that while jets were now a reality, many leaps and bounds could still be achieved. And while the Hunter has long been phased out of the armed forces, it still holds to this very day a very special aviation record. The 1958 aerobatic feat of having 22 of these aircraft conducting a loop while in formation. Thank you very much for watching, and I want to thank the Musée Clin in Payerne, Switzerland for letting us film and their exhibits. All information of the museum in the description below. And if you enjoyed this content, please do consider supporting future videos via Patreon or PayPal, as this helps me produce this kind of content. And remember to share this video. Have a great day, good hunting, and see you in the sky.